In the last part of Chapter 8, we're going to talk about concentrations and how we can change concentrations and how we can calculate concentrations. So when we talk about concentration, basically we're saying how much solute is dissolved in the solution. How much solute is dissolved in the solution. Okay, and that's important because if you think about it, if you're calling for a 2% solution and you give somebody a 10% solution, that could be life or death, right? So concentration of solution tells you how much is in there, and you don't want to exceed that, and you also can give too little. So you can do this many different ways, and so we're going to talk about some units of concentration and how you calculate those. So your weight volume percent is grams divided by 100 milliliters, or grams divided by milliliters. Okay, so a weight volume percent, you've got weight on the top in grams, and you've got volume on the bottom in milliliters times 100, and that gives you your weight volume percent. So an example here is vinegar. Vinegar contains 5 grams of acetic acid per every 100 milliliters of solution. So the weight volume percent concentration of that is 5 grams of acetic acid per 100 milliliters of vinegar times 100, and that's going to give you 5% weight volume acetic acid, and that's a very standard. And if you've ever thought about vinegar and how you don't like to smell it, that's why, because it's an acid. Another way to do it is volume. How many milliliters of solute are dissolved in how many milliliters of solution? And so alcohol, rubbing alcohol that we all use at home, has 70 milliliters of isopropanol or 2-propanol in 100 milliliters of solution, water. Then the volume percent is going to be 70 milliliters of propanol per 100 milliliters of rubbing alcohol times 100%, and that is 70% by volume, or volume of the 2-propanol. So sample problem 8.5, a saline solution used in IV drip contains 0.92% weight volume of sodium chloride in water. How many grams of sodium chloride are contained in 250 milliliters of this solution? By the way, that is the percent of salt in your blood, or what it should be. And so that's why normal saline is very, very close to your concentration. That's why they can give it to you if they need to get some liquids in your blood, and it won't cause any problems. So first you look at your known quantities. You got 0.92% weight volume of a solution in 250 milliliters, and you're wanting to know grams of sodium chloride. Now remember, weight is going to be in grams and volume is going to be in milliliters. So this percent, this concentration, can act as a bridge between your milliliters and your grams. Since it's a conversion factor, I can either write it this way or I can write it this way, and I just choose which one is going to allow me to cancel out what to start with, because the 0.92 grams per 100 milliliters is a concentration. I cannot hold that in my hand. It's not something I can measure. So 250 milliliters, however, I can measure. So I start with that amount, and then I put my concentration with my milliliters on the bottom. So 0.92%, 0.92% is the same thing as 0.92 grams per 100 milliliters if I'm talking about weight volume. Alright, and so 250 times 0.92 divided by 100 gives me 2.3 grams of sodium chloride. So I wouldn't want you to give me that because I'm on a low sodium diet. So 2.3 grams of sodium chloride would not be good for me. I'm supposed to have 1.5 in a day, but sometimes you have to give me that IV anyway, right? So 2.3 grams of sodium chloride would be in 250 milliliters of normal saline at 0.92% weight volume. Another way to express concentration is with parts per million. And in parts per million, basically what you're saying is your mass of solute in grams divided by the mass of the whole solution, not the solvent, times 10 to the 6, which is a million. A million, okay? And so, and again, you can do it in grams over grams, or you can do it milliliters over milliliters. Either way, you can express that as parts per million.